Okay, yeah, we tried to update the title, but I failed a bit with a quick update, and it shows the old title, but like this already evolved. So the title is Bound by Light, and so we'll be exploring how the speed of light affects the governance solutions for and consensus in the age of AI. So there are a few questions that I would like to explore, and probably even a few more. So the basic question is how do we find differences between the consensus and the blockchain protocols and the consensus in a human politics? Like, are there differences? Are the differences only because of the formalizations, or also because of speed of execution? What happens if we move the consensus decisions to AI, to agentic AI entirely? Then whether we can compare the ideas of jailbreaking LLMs and persuasion for people, and what are defense mechanisms, and actually how this aspect of time and speed of light changes everything in the context of do we have to be worried about super centralized, super intelligent AI, or maybe there are some expectations that will not happen. So first of all, let's summarize that decentralization kind of exists naturally. It's 8 billion people. Everyone is taking decisions by themselves, and they create institutions, legal systems, cultures, religions, and so on. And in a way, there is the aspect of propagation of information and how quickly we can get information around the globe. And nowadays, we use the systems where practically we use speed of light and for propagating information around the world. But historically, obviously, it would be much, much slower. So our ability to collect data would be very localized, and then you would wait maybe 1 or 2 weeks to manage your empires. And this all affects how good decisions and how good consensus you're arriving at in collaborations with others. And obviously, blockchain consensus is actually allowing the remote nodes to agree on something together, and they ensure data consistency, reliability, and network security. But it generally means taking the decisions where you agree on them together, auditable decisions, and if you add on top of it the governance and culture, then those decisions should be positive and affecting everyone in a positive way. And when you think about Bitcoin, it starts with proof of work, so massive computation and solving puzzles. And solving puzzles in Bitcoin and racing for who solves the puzzle first is considered generally as wasteful. But also it has this very nice characteristic of bringing the most natural resource of energy and proving that you really are in control of power, and you cannot fake it, you cannot game it as just sheer access to energy. I mean, like, you kind of can game it with ASICs and so on, but generally it's pretty pure, right? And then, well, in the past, Ethereum and Bitcoin were both on proof of work solutions, with Bitcoin being practically all on ASICs for SHA-256, and Ethereum having mostly GPU miners before it transitions to proof of stake. And those two systems on a proof of work, but also proof of stake nowadays in Ethereum, they don't have the instant finality parameters that PBFT consensus solutions have, like with Tendermint as a special case, providing immediate finality and slightly different liveness conditions. But I'll focus a bit more on those situations when you don't have finality and why that computation matters. And particularly in the case of introducing AI, the computation matters because also the governance becomes a bit of computation intensive. Like nowadays you have intelligence of humans, but in the future you have intelligence of AI. So in the proof of stake on Ethereum nowadays, everything is based on how much you stake assets, like Ether assets. And it's slashable if you try to attack the network. Like, there are conditions that would cause you to be slashed if you try to lead everyone away from the consensus. And this also has like scaling centralization risks. Like the more money you have, the more capital you have, the more you can centralize the stake and potentially attack the network. There are also limitations of communication overhead, so that's what leads practically to no finality no instant finality in Ethereum, because we have 1 million validators and they don't exchange full information. There is some set of selection, randomization, and aggregation of the decision making and then attestations. There is some work at Ethereum research communities to lead to instant finality. And maybe one comment that maybe you can try to explain it that indirectly it's still proof of work, because sometimes someone has to produce that capital through work, maybe some more useful work in most of the cases. But if you produce the capital through proof of work on Bitcoin, and imagine that the economy entirely moves to blockchain production of the value is of the monetary supply is always through Bitcoin, then in a way proof of stake becomes a bit of proof of work. And then in the traditional systems with like people coordinating, we have the ideas of elections, and then the idea of attacking and defending against the collusion, bribery, and so on is through elections, and you have persuasion, manipulation, misinformation, fake information, and so on that causes the trouble with people deciding what the result of election is, choosing the right next block for the future. But also if you go even further, then you can have an idea of reorganizations the same way as the organization on blockchain is trying to rewrite the history by amassing a lot of computational power. But in the case of the human society, if you have enough of the persuasion power, that you could potentially convince the society that the result of elections that they assumed was correct and was like even written in the history books was different, right? So you can start rewriting history, and this is a bit of reorganization of the consensus in the sense of the end of the human civilization. Obviously, the same as for blockchain. The over time consensus solidifies around the auditable historical data. It's harder and harder to convince others about history being wrong. And generally, each time you try to undermine consensus through the attacks on this agreement on consensus, you undermine trust in the system. And the blockchain governance around the technical aspect of the protocol is already the community, core developers that decide what the protocol rules are, but also cultural norms. And you think that like each time one is failing, you lift it a bit to the higher level. So if you have the failing technical consensus for the bugs or misinterpretation of rules between the clients that progress the blockchain, then core developers may achieve like some social consensus on what the update is and what the valid path was. So the contentious fork may arrive from the bug in the system, but more likely contentious fork arrives actually from disagreement between core developers on what is right, what is wrong. And then it's the community that selects which chain is correct. And then you lift it even more to the cultural norms, and you say that if one of the blockchains chooses some kind of community decision that is totally against what is accepted culturally, globally, then maybe this will become like banned, and you create a totally new blockchain, and the entire society switches to new blockchain and abandons the previous one. So we did it for the hard forks, network upgrades, all the governance elements like the Ethereum improvement proposals. There is a discussion process. It takes time, lots of discussions, lots of forums, access, information for everyone, community to be able to support it. And there's 3 levels of cultural governance and technical consensus that all of them can lead to forks and not disagreements. And a bit more from the Ethereum world, you have here examples of the calls, of the core dev calls, the research discussions on the forum, and the Discord forum on DiffRD that stopped with lots of Telegram discussions, in-person communication, and still it's all about how quickly information about all the data relevant for achieving consensus spreads, right? So on one side you can have the transactions from the mempool spreading around the world faster or slower, but also you have information about the opinions of all the key community leaders or core developers. It also spreads with some faults on the way. Like, so you not always can expect that you are not misinformed about opinions of other core developers and the community members. And then, like, if we introduce the AI governance, it means that we start replacing core developers by AI, and maybe we also replace the community by AI, and practically entire discussion and also the processes of calculating and progressing blockchain gets replaced by some calculation that is probably GPU intensive in decision that is either pretty fuzzy on LLM side or very technical, as you have the procedural processing of the protocol rules, and this is computational more like in the CPU generalized way. The question is, does it lead to some new centralization risks? Are there any limits to the centralization risks? Because I think that many of the people in the blockchain space are wondering, so if there is super intelligent AI, will it centralize everything and you have just one AI managing everything? There is no need for a blockchain. If the AI is about to arrive and communicate with the core developers, should core developers even care anymore? We're just setting up like the remnants of the culture, of the values, of the ideas of decentralization, but soon will be taken over by the much more efficient coders, developers that can design those rules. And also within the governance, do we even have any meaning in the DAOs, like decentralized autonomous organizations governance, or not? So all those questions remain, and I'm thinking of, is there any hopeful path that shows actually there are like theoretical limits that say not everything will be good with decentralization and we are still important? So in DAOs, well, this is a bit like the next layer on blockchain. On blockchain, usually you have this like very fast processing of the rules, or at least in the blockchain world, very fast. And then you have a slightly slower process of the governance through the DAOs that are deployed on blockchain. And you can imagine agentic participation that agents start acting as verifiably incorruptible delegates, right? So especially if we have LLMs and if with the work also done here at Stanford, and others, this will be about verifiability of the agents following the rules and being able to predictably say, yes, I may be not adapting to the novel conditions, but I will always be following some cultural norms of not being corruptible, bribed, and so on. So you can delegate quite a lot of work of the DAOs governance to the agents. So this can be incorruptible delegates, can be consistent regulators of the markets, and suddenly those aspects that are very fuzzy and have to adapt to new conditions and can adapt to some level of volatility, not to total regime changes, shifts, but to some unexpected outcomes. They can replace a lot of human governance and make it faster and accelerate the entire blockchain execution. And then obviously still we have questions like how much of an improvement do we have? Like with people in governance, you have problem of over time, maybe people lose their dedication. Maybe they lose interest, maybe they lose memories and simply decline and stop being efficient governors. Maybe they get busy with something else, right? So could it potentially happen with agents as well? Like, do you imagine that whenever we progress with agentic LLMs, they over time select something that's more interesting, and whatever they leave behind has the same kind of maintenance issues, that the agents that are left behind are not being adapted to the novel conditions because it's a waste of time. It feels like this is less interesting than the pretty high-scale strategic decisions that the most advanced models in the future will be trying to resolve. And in all of the situations when you have agents that you have questions about how much you can execute jailbreaking and trying to convince them to take some decisions, right? Like if you know verifiably how the agents will behave, then practically jailbreaking becomes verifiably easy. However, you can create also lots of verifiable tests and know that in all the expected conditions, you can have the agent behaving in some particular way, and then you can have maybe a collective set of agents that are verifying some potentially unexpected inputs that are attacking the other agents. So practically persuasion on the governance level is all about very careful communication with people and maybe over time convincing them to act in a way that is against what's something that they used to believe or community would like. And the same with agents, you can do careful prompting and sending them jailbreaking messages. And it means that you can lead to reorganizations, and there is a question whether with the powerful enough superintelligence, would you be able to start rewriting history, right? And then that comment on GPUs, so the GPU power becomes a bit of like defense mechanism and proof of work or proof of stake of how much you can defend against all of those different persuasion techniques, Sybil attacks, and the denial of service attacks of various governance comments from the community. Community may become totally fake. The core developers may become fake and start sending messages in large numbers, and then you kind of start not having any confirmation of what is true, what is not. But if you have on one side the cryptographical mechanisms for verification of truth, that is good. On the other side, you can have also defense mechanism on the being able to process much more than the attacker. But yeah, like in the very bad scenarios, the AI may take over and may start rewriting human history because practically the processing power that we had on the past, it's a bit like with blockchain. The first early blocks were mined with not much of the GPU power, and practically the first blocks of the human history were mined with a bit of just like no processing power at all. Then the AI may totally ignore the thousands of years of human history, rewrite it, and just focus on the latest GPU ability to rewrite everything and train new AIs with this new history, and then our history disappears, right? So the truth disappears, and maybe it even becomes irrelevant because the amount of data and the pace at which we are progressing from the perspective of AI, the new one, is so much more that it becomes so irrelevant as maybe like first few blocks on Ethereum or Bitcoin. They might be culturally relevant, but not always for data. Well, some of them are actually super important for the initial minting and so on. And sorry for that. There's a bit of a delay in the clicker, and okay. All right, I'll do that here. So there is a question of scaling between like people and agentic systems. So do agentic systems scale based on like how quickly they can take decisions? So will they be able to take decisions much faster than people? Most likely, yes. Do they scale on the level of distractions? Like, so practically, the more fake data, you have to produce much more fake data for the agents to be confused than for people. So does it scale linearly or like in any other way? Maintenance costs, like is there totally different maintenance cost of the AI growing and leaving some old style of LLMs behind? And do they want to execute maintenance, or maintenance is almost for free with the agentic systems? Do we scale memory? So will there be really infinite context, or practically as everything else scales, like there's so much more to remember that even as you can remember much more, you start forgetting. And well, does it also scale on distances? So would the AI and LLMs be able to operate at any distances between the planets and beyond and so on? And well, for the defense mechanisms, even with larger scales, you probably want to have aspects of collective intelligence with multiple LLMs working together, looking at the contextual historical consistency of all the data. So you have all the mechanisms that you nowadays use in governance, and detecting anomalies in like potential attacks. As like when you observe runtime information on blockchain, we try to check whether there's element of surprise, and I think the element of surprise could be probably quantified in the LLM's reaction to input. And we can also introduce all the aspects of the latency of like normal governance on blockchain introduces latency as like if we take decision that is affecting significantly consensus, then maybe after introducing it into the protocol, we leave a month or 3 months for people to review it and test it and integrate it. On the smaller scale, maybe this will be a few hours where agentic AI tries to introduce the latency before introducing changes. All of this probably scales and becomes like rescaled, but naturally very similar to the behaviors of people and human core developers. Now, when you start thinking about all of this, then data and time actually is related in a way that data quality or like relevance decays over time, right? So practically, the data becomes like moves from the point of decision to consensus to something that becomes a knowledge and a training data if it's not changing, right? But the data that is very temporal for a moment. It's never landing with the training set, but maybe it lands with the training set as a data pattern. And there is some limit on how much of the past data you want to collect. And when you take the consensus decisions, that you can only use the data that doesn't get obsoleted before you can reach the consensus with other agents. And similarly, you have the decay of the data over distance. Now, so the data becomes very often much less relevant as you're becoming much further away from the data source. Why might be so? Because for trading, if you have information about, let's say, earthquake on the other side of the earth, then if within the first 10, 50 milliseconds, the local traders reacted and moved all the decisions on the market on that data, then the moment that data reaches to the other side of the earth with like 130 milliseconds delay, data becomes less relevant. Yes, 1 minute? Yeah, I see it. So similarly, we have limitations of where we can achieve the consensus, and there should be a centralization limit that is defined by how much data temporarily and locally you can collect, and there is no sense to achieve consensus on a more global scale. So you don't want to do all the data historically and globally, so maybe there is a limit that says that all the blockchains should be regionalized. So the regional sharding is inevitable. And regional is sometimes also domain, because domain allows you to process something faster. And then it means that superintelligence may start behaving on like much higher hierarchy levels in a way that that becomes so distant for us and so irrelevant that it becomes like natural phenomena. The last 2 slides. Also, to process everything faster, you have the value of truth and transparency. So the more of the verifiability, like cryptographical verifiability you have, the more of the information you can process and better decisions you can take. And similarly, the value of privacy. Privacy moves between this data provider and the limitation of centralization. So you have the balance between how much privacy you want to sacrifice, and maybe you want to sacrifice it for only for machines, but not in the human-to-human situations. Okay, so should the blockchains be geographically sharded? Will they be? And is there some kind of inherent relation between centralization and speed of light limitations of data propagation? Thank you so much. So how the cases of like delegation can reduce the centralization risks. I think like if you think that there is geographical locality, that if you can delegate regionally, then you kind of sacrifice that centralization, that you take all the decisions in a delayed way. I think that centralization becomes a problem, like the dictatorship becomes a problem when the centralized actor starts taking decisions based on the data that, decisions that affect you, based on the data that you produce, but it's already too late to take a good decision. So you want to delegate locally, and then delegating locally means a bit like it's a decentralization, right? So you're delegating the power, and then just hierarchically collect the points where you want to do a bit of integration on the higher level. I think it touches like decisions, data, MEV extraction. So you have lots of opportunities for localized extraction of opportunities or value of power. But then the higher levels actually don't affect the local situation that much as we would fear, which means that superintelligence maybe will be taking decisions on the level that with a massive delay affect us, or maybe it will affect us drastically, but it will be the same effect as some kind of astronomical collision.
Cool. All right. Yes,
Yeah.
we should move on. All right. Thank you so much.
Thank you so much.